We shall find the unit of rate constant. Rate law is written as rate is equal to K into concentration of A to the power X into concentration of B raised to Y. From this rate law, I can write rate constant K is equal to rate divided by concentration of A raised to X and concentration of B raised to Y. So here rate is change in concentration of reactant or product with respect to time, and in the denominator we have concentration of the reactants X and Y. So I can write this as concentration to the power N, where N is order of the reaction. So the SI unit of concentration we know that is molar, that is mole per liter. The SI unit of time is second. Substituting these SI units in the expression of rate constant, we can write the unit of rate constant as concentration is mole per liter divided by time, that is second, and this is divided by unit of concentration, that is mole per liter, its power N. Using the laws of exponent, I can write this as mole per liter per second, and in the denominator we have mole per liter to the power N, that can be written as mole per liter to the power minus N. Further simplifying using the laws of exponents, I can write this is mole to the power 1 minus N, liter to the power minus 1, minus of minus N is plus N, so it is N minus 1 per second. So this is the unit of K in general. Now let us find the unit of K for a zero order reaction and for a first order reaction. We know that for a zero order reaction, rate is equal to rate constant. This is because zero order reaction is the rate is independent of the concentration of reactants. So unit of K is equal to unit of rate. So we know that rate is change in concentration of reactant divided by time, and the SI unit of concentration is mole per liter. SI unit of time is second, and therefore unit of K for a zero order reaction is mole per liter per second. So this is the unit of K for zero order reaction. Now let us try to write the unit of K for a first order reaction. We know that for a first order reaction, rate is directly proportional to first power of the concentration of reactant. So I can write rate is equal to K into concentration of R raised to 1. K is equal to rate divided by concentration of R to the power 1. Rate is concentration divided by time, and in the denominator we have concentration to the power 1. SI unit of concentration is mole per liter divided by unit of time is second divided by concentration to the power 1, that is mole per liter. So mole per liter in the numerator and mole per liter in the denominator both gets cancelled with one another, and we have is 1 by S, which is nothing but second inverse when second is taken to numerator, and therefore the SI unit of rate constant for a first order reaction is per second.